Okay, my heater flash video was cut short, so now I'm continuing it. So if you observe that your tube has a heater flash or develops one, that when you turn on you see the very bright flash and then it subdues, then that's a sign that the filament of that vacuum tube is going to die very soon. Perhaps 100 turn on off cycles, but probably not more. And it means that every time you turn your amp on and off, it's going to get worse and worse until the point when you turn it on, there will be a bright flash and then there's no light. The tube will not light up anymore, and then you will have a dead tube on your hands. When you have this bright flash, the tube still can sound very good, and it still can be a very good sounding vacuum tube, because its cathode might be still very rich, not depleted, and it can have high transconductance. It's not guaranteed to have one. If it was a good tube before the heater flash developed, it will continue to be a good sounding tube. However, it's a sign for you to get started right away looking for a replacement tube. And probably you want to keep that tube with a heater flash as a backup for the occasions when one of your tubes gives up the ghost and you don't have a replacement right away. Then you can use it as a replacement. However, I do not recommend using such tube for everyday duty, and if you are forced to use one, then use it only in an amplifier that can be turned on at all times, because each time you turn it on and off, you are bringing it close to popping it. However, if you just keep it on, like if I were not to turn off the phono stage, then it would live just as long as any other tube in this unit, because then the filament is not going to go through another annealing cycle. And it's the annealing cycles of turning on, turning off, that gigantic heat differentials. Basically, it's a 1000 degrees Celsius change during each on-off cycle, and that's just tremendous. However, if you are not subjecting your tube anymore to that, you keep it on, you keep your preamp, amp, whatever on, then that filament will be just as happy as any other filament of the other tubes. However, in that case, if the amp is turned on continuously, that's very good for the filament, but it's depleting the cathode. So, as you see, there is a balance in the universe. So if you keep your amp on at all times, then there is a faster depletion for the cathode, but the filament keeps happy. If you turn it off, then you conserve the cathode, but you are aging the filament. In the case of the signal tubes, leaving them on at all times for most tube units is a better choice, because in the case when these tubes are not run very hard. Usually when you touch these tubes, these are not too hot for the touch, because signal tubes are not being run at top plate. Dissipation may be at 50%, 20%. I would say like 20% is more usual. And when it's run at 20%, then the cathode depletion process is extremely slow. So if you have a preamp with such small signal tubes, then you could technically just leave it running at all times, and even after 50 years the tubes are still operational with being continuously on. And that's what we observe at the radio stations. So where the radio is amp at the station is constantly operating, there are some input tubes for the radio transmitter amps which have been continuously operating for 100,000 hours. and they are still happy and strong. However, the power tubes, they are run at much higher plate dissipation, usually close to 100% of the maximal plate dissipation, and that depletes their cathode very fast. So for them, it's better if you keep the power tubes off when you are not using it to prevent the cathode depletion. One design parameter that you can do to prolong the life of your vacuum tubes is, instead of 100%, run it lower. So I'm running them at 80% plate dissipation, which gives a much longer time span. And also my on-off switch, it just switches the high voltage. So all of the filaments here are constantly on, and I'm not doing any wear and tear on the filaments, neither on the signal tubes, neither on the power tubes. So when I turn the amp on, then the only thing that is getting switched on is the rectifier tube, and then it starts conducting and giving high voltage to the others. Of course, the high voltage is also kept turned off, so the high voltage turns on and the filament of the rectifier turns on as well, and that keeps the high voltage supply to the rest of the unit. So this is the longest tube life scenario possible for an amplifier. Eventually there's another scenario that would give even longer tube life, is if you had a switch where you could switch the high voltage from 100% to about 30%. So the tubes like it even more if their filaments are on, but the voltage across the tube is much less. It means then that there's much less current running through the tube, and there's extremely minimal plate depletion, and also it's being kept at a warmer temperature. So when you flick between 30% to 100%, there is much less stress on the metal elements inside. How you could even improve that situation is that not just go from 100% to 30% for the high voltage, but for the filaments also drop from 100% to 70%, so that the filaments are not running as hot either. So thank you for tuning in. I hope this helps a little bit about vacuum tube life and understanding of the heater flash and when you need to replace your tubes. Thank you. Please like, subscribe. Bye bye.